Figure 19.8 Sort1.java. In this example, we're going to demonstrate one of the collections classes sort methods, in particular one that is capable of sorting an existing collection, an existing list in particular, of items that are already capable of being compared. And before we actually take a look at the example, what I'd like to do first is go look at the collection class in the online documentation and take a look at the specific version of the sort method that we'll be using. So let's go over to the online documentation set. I've already pulled up the class collections from the java.util package. I'm going to go to the method summary and scroll down to the S's, where we will come across went a little too far here, where we'll come across our sort method, and particularly this is the version that we're using. And I'd like to talk specifically about this line of code that they show in the documentation. First of all, we'll see that the name of the method is sort, that it returns void, and that it expects a list of some type as its argument. Now, the interesting part of this first line of the function, if you will, is this piece over here, which is the so-called type parameter list for the generic method named sort. And the type parameter list introduces the fact that T is the generic type name that we'll be using in the sort method. But more importantly, it says that there is a requirement for anything, any type that's going to be used with the sort method. And the requirement is that that type has to implement the comparable interface. In type parameters specifications or type parameter lists, the extends keyword is used not only to specify that a type must extend a particular class, but also to indicate that a type must implement a particular interface. So we're indicating here that the generic type, whatever it represents, must be some type that is comparable, and this description right here is basically indicating that two items have to be comparable to one another in order to be sorted. So if you take a look at the types that we're going to use in this example, we're going to be sorting strings. So let's take a look at the string class first to make sure that strings are indeed comparable. So again, I'm going to go back to the doc set. Now, string is in the java.lang package. It's one of the fundamental classes in Java. So I'm going to go pull up the string class. And as it comes up here, the thing I want to look at specifically is this piece of the class's description, which indicates that class string extends object and implements several different interfaces, the key one in this case being comparable of string. So a string is comparable to another string, and the interface comparable says how to perform the comparison of two objects. So if I click on the comparable link, I can go look at the method that is expected in a comparable object, which is called compareTo. The compareTo method is called on one object of a given type and receives another object of the same type. That's what the T represents. And it returns an integer indicating whether or not the object that's being used to call the function is less than, equal to, or greater than the object that is received as an argument. So it gives a negative number if the object is less than the object received as an argument, 0 if the objects are equal, and it returns a positive number if the object calling the method is greater than the object passed to the method. So basically what it comes down to, actually let's go back to the sort method in the online doc set here. What it comes down to is that in order for sort to work, it must be able to make this method call where E1 and E2 are two items in the underlying collection, and be able to determine from that method call the sorting order of the two elements. So going back to our program now, we have this static final array of strings called suits, hearts, diamonds, clubs, and spades, and you can see that they're clearly not in alphabetical order. Down in our main method, we create an object of our class Sort1, and we call its printElements method, and printElements does all of the work in this example. The first thing we do is we obtain a list reference by calling the arrays.asList method on the suits array. Now, we're not going to modify the size of the underlying array, but we are indeed going to sort that array. And in order to do that, in order to take advantage of this built-in sort method of the collections API, what we're going to do instead is create a list view of that array, assign it to a list variable, and then we're going to output the list variable, which will actually convert the entire collection into a string representation. We'll show you that in a moment. And then we're going to say to sort that list using the collections class's sort method. Now, this will only compile if the list is a list of some sort of type that knows how to be compared using the comparable interface. So strings are comparable. For example, also all of the type wrapper classes built into the java.lang package, objects of those classes are comparable. So you can use things that are already comparable with this version of the sort method, and in a subsequent example we'll show you how to create your own way to compare objects that are not already comparable. So we're going to sort the objects in this case, and then we're going to output the collection once again by giving the list reference to this %s specifier, which is going to convert the list into a string. If we run the program, you'll see here in the output window that the unsorted array contains hearts, diamonds, clubs, and spades. And notice, by the way, the syntax that the list was converted into for its string representation. It consists of a left square bracket, each item separated by commas, and a right square bracket. And then we sorted the elements and printed them again in string representation, and we got clubs, diamonds, hearts, and spades, which are clearly in alphabetical order.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than Live Lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live Lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.